So when we're writing equations of lines, we've got to figure out what are some things that we can pick out and what things show up in the actual equation. The one thing that I said that all of us should be able to do is figure out what is the slope. Okay, so remember slope represented by the variable m. We're looking for a rise over run. Now, when we're doing this from a graph, we want to be specific with the signs. And on top of that, just thinking about this line, before I even figure out what rise over run is this a positive slope line or a negative slope line? Good. Okay, we've got that down. So I know that when I write my slope, it's got to be positive. Now, how I can figure that out is I'm going to connect any 2 points, and I'm going to figure out if I go from one of those points to the other, what is my rise over run to make that happen? Well, if I start at point A, I'm having to go right 1, which is positive 1, and that's the run. Run is how far over we move. And then I'm going up by 1, 2, 3. So then plus 3 for the rise. So my rise over run is a positive 3 divided by a positive 1, which is just simply 3. Okay, so no matter what form we write the equation in, we need to find the slope. I would always start with that. The next decision that we want to make is which form do we want to write the equation in? And really, it should be one of 2 forms. Okay, we've talked about a third form, but you're either deciding mx plus b or the point slope form of y minus y1 equaling m times x minus x1. So let's think about what points need to show up in each of these equations. If we do mx plus b, this b is the y-intercept. Can we clearly see where this graph crosses the y-axis at? Yeah, right? It's this point right here at C. This is our y-intercept, and thus that would make the value of b just exactly what that y-intercept is at 2. So most people, when they're asked to write the equation of a line, will go to just jump straight into this slope-intercept and say that this equation is y equals positive 3x plus 2, and you're done. I'm going to ask that we also think about how could we write this equation in its point slope form, because there might be equations or graphs where we can't clearly see where it crosses the y-axis at, or maybe it's in between numbers. Maybe that y-intercept is in between 2 and 3, and we don't want to just guess and say, oh yeah, it's like 2.5 or 2.2 or whatever. We want to write the exact equation. So if we can't figure out where it crosses the y-axis, then we need to use the point slope form. And in this point slope form, this x1, y1 represents any point on our line. So the only thing that we need to do is find one point that shows up on this line, and we can use that in the equation. Okay, so both forms need the slope. Y slope intercept needs the y-intercept. Point slope, we just need any other point. So let's use point D here. Point D has coordinates of 1, 5. So I'm going to use the point 1, 5, which is x1, y1, and I'm just going to plug it all into that formula. So it'd be y minus the y coordinate, so y minus 5, equals the slope of 3 times x minus our x coordinate of 1. And this is another equation to write that same line. And know that these two equations are the exact same. They're just in different forms. If I were to take this point slope form and distribute the slope and add 5, we're going to get the exact same thing. Okay, so with this lesson today, we're going to mostly focus on the point slope form, but know that slope intercept is also a way that we can write the equation if we can clearly identify the y-intercept. Okay, well, I basically outlined everything we need for this next slide, where it says, so what information do we need to write the equation of a line? We need the slope and a point. And let's change this point slope form to y minus y1 equals m times x minus x1. You know, we already did that. All right, so I'm going to do number 1. I'm going to have you all do number 2. And we'll flip this page over and go from there. It's looking like we should get some work time in class today. I can also come do a homework check. All right. So write the equation number 1. I'm noticing that it is a positive slope, so I know no matter what, that slope needs to be positive, whatever my rise over run ends up being. I'm going to connect any 2 points that I can find that intersect at nice, even numbers. And I'm going to check my rise over run. For the run, I'm having to go over 1, 2, 3. So my run is positive 3. The rise, I'm having to go up by 2. So that rise over run, or that slope, is 2 over 3. And then again, the point that you choose, as long as it's any point on that line, it doesn't matter. So the point that you choose could be different than somebody else in your group. Okay, they might pick a different point. I'm going to use this one up here in the top right. Actually, let's not do that one because the coordinates are kind of the same. Let's do this one right here. Okay, that one is 2, 3. And now I just need to piece all this together and plug it into my point slope form. So y minus 3 equals 2/3 times x minus 2. All right. I'm going to ask that you all do number 2 in your groups. When you go to write the equation, let's use this point right here as the point that shows up in the equation. That way we can keep it the same for everything that you all write. Okay, find the slope, identify the coordinates of that point, put it together in an equation. Give you 2 minutes. Okay, so slope, first thing I notice of this line, that is a negative slope line. It's going down as we go to the right side of this graph. I notice my rise is 4. And again, the sign of it doesn't really matter, especially if you pick up that your slope just in general is going to be negative. But I'm starting at that upper point, and because of that, that's having me go down 4. And then I'm going to the right 1. So by going right, that makes that run a positive 1. So the slope's negative 4. And then I ask that we all use the same point. That way we just get the same equation. And that being 7, negative 8. And then just be careful, because what tends to happen? Students will be like, oh yeah, it's 7, negative 8. But when we write the equation, we use the y coordinate first. And in a point, the x coordinate gets listed first. So it's really common for students to say, this is y minus 7. Be very mindful of what your x and y coordinate are and where they show up in your equations. Okay, so y plus 8 equals negative 4 times x minus 7. Question? Huh? Yeah, that's 7, negative 8. This point right here is 7, negative 8. You're good. No. If we have questions, I want you to ask them. Or if we're confused by something, I want you to speak up. Okay, once you've got this down, flip this page over. Okay, I'm going to show us a couple things here, and I'm going to make this a little bit longer, but then you can kind of do really whatever you want. So here's why, like on the last one, on these last graphs, I can't for sure say what that y-intercept is, right? That's somewhere in between 1 and 2, and it looks like it should be 1.5. But can any of you guarantee that this y-intercept is 1.5 just by looking at it? No, we can't guarantee it. Okay, it could be 1.52, 1.53, 1.67. We have no idea. And that's why the point slope form is more relevant there, because I can't say for sure what that y-intercept is. But now with the ones that I'm asking us to graph, because I can clearly see that it is crossing the y-axis at 2, I can save myself a little bit of work and just write this in slope-intercept form. So that is something I want us to consider as we're writing equations. What form is going to be better to describe this graph? And it is all dependent on whether or not we can see the y-intercept here. So for this graph, let's at least find the slope. That's one of the easier things to do. I'm having to go down 1, 2, 3, 4. And I'm having to go over 1, 2, 3, 4, 5. That is definitely a negative slope line. So my rise over run is negative 4/5. And the point is 0, 2, which tells me that b equals 2 in mx plus b. So this equation is y equals negative 4/5 x plus 2. Now let's say on your quiz on Friday, you get used to writing all your equations in point slope form. And so on the quiz, even though this graph crosses the y-axis at a really nice point, you instead say, hey, I want to write it in point slope form. And you choose this point right here, which is 5, negative 2. And so you write your equation as y plus 2 equals negative 4/5 x minus 5. Do you think I'm going to count that wrong? Absolutely not. Okay, as long as you give me a correct form of the line, I don't really care which form it's in. Now, down the road, I might say, hey, write the equation of the line and then be specific about the form. So let's say I want you to write this equation in slope-intercept form, but you don't remember how to get the y-intercept for whatever reason. Well, you can always start in point slope form, and then look what happens if I try to get y by itself here by simplifying. If I distribute this slope, that makes this y plus 2 equals negative 4/5 x, and then negative 5 times negative 4/5. Well, this multiplication, and you can check that with the calculator, is going to end up being a positive 4. So that'd be y plus 2 equals negative 4/5 x. Negative 5's cancel, so plus 4. So that's just me multiplying that fraction. And if I then subtract 2 here, I get y equals negative 4/5 x plus 2. Does that look familiar? That is the exact same thing we got when writing it in slope-intercept form. Okay, so you could also convert between forms. And it's really easy to convert from point slope to slope-intercept. Okay, you all write the equations of the next 3 lines. I'm not going to go over the last 2. You can jump right into that. That's an easy thing to remember from what we did on Friday. I'll give you 3 minutes, 1 for each graph. Ready to go. All right, looking at number 4 here. Your slope, that is a positive slope line. Rise over run is 1/2. So up 1 over 2. The y-intercept is at negative 4. So putting this into slope-intercept form, it's y equals 1/2 x minus 4. Okay, I'm not switching any signs, just exactly what I see the y-intercept is, shows up in the equation. Slope stays the same. Now, one student that I had asked a question like, what if I took that y-intercept of 0, -4, and I wrote it in point slope form? That's absolutely okay. Where the y-coordinate is -4, x-coordinate is 0, this absolutely works. And once again, this is the same form or the same line or same equation as what I wrote in slope-intercept form. And the conversion is really easy, right? If I multiply the slope, well, I get y plus 4 equals 1/2 x, and then 1/2 times 0 is just 0. So then for me to get y by itself, I just subtract 4, and there we go. Okay, I have the exact same equation that I originally wrote in point slope form. Or excuse me, slope intercept form there. So again, you have to know both forms. Okay, just writing everything in slope intercept will not work for what we're doing in here. Going point slope form isn't going to work for everything we're doing in here. Last thing, your horizontal and vertical lines. This is an easy equation to write, but you need to take not even that much time to study. If you take 5 minutes outside of class and just process that every horizontal line is y equals some number and every vertical line is x equals some number, that's an easy thing that you're going to get right every single math class you have here on board. Okay, and what's going to happen, okay, because somebody asked, like, I forgot how to do this. Well, think about what stays the same. When I write the equation of a horizontal line, every point on that line has a y-coordinate that doesn't change, right? We don't care what x is. On these lines, x is always something different, but the y stays the same for every single point. Opposite of that are vertical lines. We get x equals some number for every single point on that line. Okay, so these should be easy. Okay, if they're not easy, you haven't taken 5 minutes outside of class to study. Okay, which is okay at this point. But that's something we should have down by the time we quiz on Friday. All right, well, that is